In this lecture here, we want to move into section 2.3, where we're going to start talking about linear functions and slope. So this lecture here has some main objectives that we're going to hit. The first thing we're going to do is we're going to talk about how you calculate the line's slope. So, when going back here, we're going to be talking about linear functions. So we know that this linear is synonymous with a straight line. Okay. So we're going to calculate a line's slope. So you might have heard slope as this concept as rise over run. Well, there's a very simple formula for it. We'll work some examples with it. Then we're going to talk about something called the point-slope form of an equation of a line. We're going to talk about how you write and graph the slope-intercept form of the equation of a line. We're going to graph horizontal and vertical lines. And then the last thing we're going to do, I have this example where we're going to use intercepts to graph the general form of a line's equation. So really what's going on here, all right, in this lecture here, we want to talk about all the components of a linear function. So a linear function is kind of a straight line. So we're going to talk about the slope. Think of slope as rise over run or rate of change. And then we're going to talk about these two main equations of a line. We're going to talk about something called the point slope and then the slope intercept. All right, so let's start first with the slope. Okay, so the slope of a line through the distinct points. So to find the slope of a line, you need 2 points on the line. Okay, so to find slope of a line, you need 2 points. Okay, and those points, those 2 points, the first one will be called x sub 1 comma y sub 1. So this is the x coordinate of the first point and the y coordinate of the first point. And then the second point we'll denote as x sub 2 comma y sub 2. So this is the x coordinate of the second point and the y coordinate of the second point. And the formula for slope, you might have heard of slope being referred to as the letter m. Okay, so slope we're going to denote with the letter m is equal to the change in y. Okay, so the change in y is my rise divided by the change in x, which is our run. Okay, so this is just equal to y2 minus y1 divided by x2 minus x1. Very, very simple formula to follow. So if you think about it like this, let me show you how this formula is derived. So you've got this first point on a line. Okay, this is x sub 1, y sub 1. And you have a second point on the line here, which is x sub 2 comma y sub 2. If you want to calculate the slope, the change in y, well, this change to go from y1 to y2, how much you change there, that's the rise. So that's just y2 minus y1. Okay, that's where that comes from. And the change in x, the run, so you rose this much. Now you're going to run, you rised that much. Now you're going to run this much. Well, this distance to go from to go from x1 to x2, that distance here is just x2 minus x1. So this is where this formula comes from. Okay. I'm never going to do it this way, but it's also the same thing as y1 minus y2 over x1 minus x2. Get the same result. It's just more commonplace to see it this way. All right, so let's do some examples here. Okay, so just remember slope is equal to change in y, y2 minus y1 over x2 minus x1. All right, so in these examples here, we want to find the slope of the line going through the points All right, so here's the first one. First one will be going through the points. Let's do 5, 7, and let's do 2, 3. All right, so this is my x1, y1, and this is my x2, y2. All right, so slope m is equal to y2, which is 3, minus y1, which is 7, divided by x2, okay, which is 2, minus x1, which is 5. Well, 3 minus 7 gets me minus 4. 2 minus 5, what does that get me? That gets me minus 3. Negative divided by a negative is a positive. So the slope here is 4/3. And it's okay to have a slope be a fraction. That's totally fine. All right, so it's really just following this formula. So let's do a complicated one here, okay? Let's find the slope going through the points 1/2, 1/3, so some fractions, and the other point being, let's do 2, minus 3. All right, so you have to notice there's a fraction, there's a negative number here, so you just have to be very, very meticulous as you go through this. So m, the slope is equal to y2. So this will be my x1, y1. This will be my x2, y2. Slope m is going to be minus 3 minus y1, which is 1/3, all over x2, which is 2, minus x1, which is 1/2. All right, so fractions here. So you need a common denominator here, right? So this is 3/1, and this is 2/1, if it helps to see it that way. Okay, so the LCD here is 3, so I'm going to change this to minus 9/3 minus 1/3 divided by 2. I'm going to change to 4/2 minus 1/2. So minus 9 minus 1, this is minus 10/3 divided by, this ends up being 4/2 minus 1/2 becomes 3/2. 4/2 minus 1/2 gets me 3/2. So then you need to evaluate this. Keep change, so minus 10/3, change division to multiplication, and then flip this. Okay, so what does this become? So this becomes, instead of 3/2, it becomes 2/3. Well, let's see what we get here. So this is minus 10 times 2 gets me minus 20. 3 times 3 gets me 9. So this one here, this slope ended up being minus 20/9. All right, class. So just follow the formula. If there's fractions in it, just be careful of that. And it's just following the formula. All right. So now we want to talk about equations of a line. So there's two forms of the equation of a line. We have something called the point-slope form of a line. Okay. So the point-slope form of an equation of a non-vertical line. So it's giving you the slope m in any point that it passes through. So this is any point, okay? So this is the point, any point x1, y1. That's just equal to y minus y1. So y here, notice how there's no number under this. Y just stays as is. So just leave it as y. Y minus y1 is equal to m, and then in parentheses, x minus x1. Okay, so what you're going to do is you're going to replace mx1 in y1 with numbers. And then the goal is, once you had it like this, what you want to do is you want to put and always write equations of lines in the form called the slope-intercept form of the line. And the slope-intercept form of equation of a non-vertical line with slope m and a y-intercept b is equal to y is equal to mx plus b. And we always want to simplify lines to this form. And this form right here is great for the equation of a line, right? What it tells us the y-intercept, so where it crosses the y-axis, it's going to cross the y-axis at b. And then that m in front of x, that tells me the slope of the line, okay? So what you're going to notice as I do these problems, okay, I'm going to show you next how we find equations of lines. I'm always going to start by using the point slope, and then I'm going to simplify the point slope to get me to be this slope-intercept form of a line. Okay, so just remember, we always want to get us into this slope-intercept form. All right, so what you're going to need, to find the equation of a line, this is really important. To find the equation of a line, you always need first thing you need is the slope. No matter what, you need to know the slope of the line. And then you need any point any point on the line. It doesn't matter if it's the y-intercept, just any point on the line works fine. Okay, so here's the problem. Write an equation for a line with slope 6, okay, so I'm telling you the slope, boom, that passes through the point 2, comma, negative 5. So look, I've got the slope, awesome. So you're given slope is 6, and you're given a point. And so the point is this x1, comma, y1. And so the point is 2, comma, minus 5. So what you're going to do is you're going to start with point slope, or excuse me, yes, you're going to start with the point slope form here. And that's y minus y1 is equal to m times x minus x1. So watch, this is y minus 5 is equal to my slope, which is 6, times x minus x1, and my x1 is 2. So now all you have to do is simplify this. So watch, negative, negative, this becomes y plus 5 is equal to distribute 6x minus 12. And now all you want to do is you want to end in slope-intercept form. So what you've got to do, if you look here, slope-intercept form has the y by itself. So you're going to take this equation, y plus 5 is equal to 6x minus 12, and you're just going to move the 5 over. So you get y is equal to 6x minus 17. And there you go. Boom. You got it right there. That's the equation of this line that has slope 6 and passes through the point 2, comma, minus 5. And what you're able to see right from this is, look, yep, the slope is 6. Boom, right there. And this crosses the y-axis. The y-intercept is minus 17. All right, let's do another one here. So write an equation of a line with slope 1/2. Okay, so you're given m is equal to 1/2. And you're given the point minus 8, comma 2. So look, again, you're going to start with the point slope. So it's y minus y1 is equal to m times x minus x1. So it's y minus 2 is equal to my slope, which is 1/2, times x minus x1. So this is minus 8. So you have to be careful of that double negative. So this is y minus 2, distribute here, 1/2, negative, negative becomes a positive. And then don't overthink this, right? Like, what's 1/2 of 8? It's just 4. Then your last step here, you're going to add 2 to each side. This is gone, and you get y is equal to 1/2 x. 4 plus 2 gets me plus 6. And you got it right there. So notice, starting point slope, simplify to slope-intercept every time. Boom, boom. Okay, now let's try this one. Let's write an equation for a line that passes through the points 2, comma 4 and 6, comma 8. Okay. So here, going back, look, this is what I said. You need a slope and you need any point. All right, so, well, this is great. I've got 2 points, but the first thing I need to do is I need to find slope. So slope is equal to y2 minus y1 over x2 minus x1. So these are my 2 points, right? So look, even though they don't directly give me the slope, I can use these 2 points to figure it out. So it's 8 minus 4 divided by 6 minus 2. Wow, this one's pretty easy here. So 8 minus 4 gets me 4. 6 minus 2 gets me 4. Nice, the slope is 1. Now use the point slope. So it's y minus y1 is equal to m times x minus x1. So at this point, it actually doesn't matter what point you use. It doesn't. You can use either one. You'll get the same answer. So I'll just use this first one. So this is y minus 4 is equal to 1 times x minus 2. Well, this is y minus 4. The 1 just distributes to be x minus 2. And then your last step, you're going to add 4 to each side. And you get y is equal to x plus 2. And that's it right there. So if you're not given the slope, so just to recap here, if not given the slope, all right, you're going to use 2 points to find it. All right, so we've got an idea now how to find the equation of a line. This is great. What we're now going to talk about is graphing these equations of a line. And so I'm going to show you methods that don't involve a table of values, because we've talked about using a table of values to graph functions. But in this case here, when you want to graph a line, okay, this is really important. When you want to graph the equation of a line, you need just 2 points. Okay, any 2 points on the line, and that'll do. So what I want to do is I want to show you graphing this y is equal to mx plus b. So they're capitalized here, but this is y is equal to mx plus b. So this slope-intercept form. Using the slope and the y-intercept. So basically, here's what you're going to do. You need 2 points. Your first point's going to be the y-intercept. So what you're going to do is you're going to plot the point containing the y-intercept on the y-axis. Okay, y-intercept occurs when x is equal to 0. So you're literally going to plot. You're just going to look at the graph and say, okay, b, that's the y-intercept. So I'm going to plot it as 0, comma b. And this part is a little bit confusing as I say the words, but after you see the first example, it's actually very, very straightforward. So then what you're going to do is you're going to obtain a second point using the slope, m. So what you're going to do is you're going to write m as a fraction, okay? And you're going to use rise over run, starting at the point containing the y-intercept to plot this point, okay? This, as soon as you see an example, this will make sense. The next thing you're going to do is you're going to draw a line through the 2 points, and you're going to draw arrowheads at the end of the line to show the line continues indefinitely in both directions. Okay, so this seems confusing how you use the slope to find a second point initially, but I promise you it's actually very, very straightforward. It's a pretty easy concept. Okay, so here's what I want to do. I want to graph this linear function. So notice now here I'm using this f of x instead of y, okay, and that's totally okay. So just remember, this is also y. Okay, so what we're saying here is graph this linear function, so this straight line. So f of x, which is y is equal to 3/5 x plus 1. So this right here, this is the slope. And this 1 is the y-intercept. Okay, so that means the y-intercept is the point 0, comma 1. So step 1, the first thing you're going to do is you're going to go and you're going to plot, boom, the y-intercept at the point 0, comma 1. So we plot the y-intercept. So now what we're going to do next is you're going to use the slope. Okay, the slope m, to find the next point, okay, for the graph. And when I say next point, I don't mean like the next point on the line. It's just the next easy point to find so that you can find 2 points on the graph to plot. Okay, so just remember, this 3 is the rise, and the 5 is the run. All right, so it seems a little confusing here. Okay, so 3 is the rise, and 5 is the run. All right, so what you're going to do is you're going to start at your point. And you go, okay, I rise 3, so I'm at 1. I'm going to go up 3. 1, 2, 3, 4. So notice I got up to 4 here. So I rose 3. And then what I'm going to do is I'm going to run. Okay, so I go run this way. All right, I'm going to run 5. Okay, so I'm at the point 0, 4, and now I'm going to run 5 to get me to the next one. So this gets me to the new point 4, 5. And then what I do from here, now that I've got my second point, is I just draw a straight line through it. Whoosh, just like that. All right, let me do some other examples so you can see this one here. Okay. Let's sketch this graph right here. All right. So sketch the graph of y is equal to 2x minus 3. All right, so first thing here, y-intercept is minus 3, which is right here. Now my slope is 2. So I'm going to write it as 2 over 1 because that's the same thing. So watch, I'm going to rise 2. So I go 1, 2 over to 1, over to negative 1, and then I'm going to run 1. So then I'm going to go over 1. And these 2 points, bam, this is my line. Just like that. Let me do another one. Let's graph f of x is equal to, let me do minus 3/2 x plus 5. Okay, so now I'm going to show you with the negative what this means. All right. So look, y-intercept. Is 0, 5. So I'm going to go up to 0, 5 right here. Now my slope is equal to minus 3 over 2. So this is rise over run. So I'm going to rise negative 3. So that seems weird, right? So you don't go up 3 because there's a negative. You go 1, 2, 3, down 3 in this case. And then you still run 2. So over 1, 2. So I rose negative 3. So that means I actually go down. 1, 2, 3. And then I run 2. So then I go 1, 2. And this is my other line here. So this one here, this is f of x is equal to minus 3/2 x plus 5. And this line here is y is equal to 2x minus 3. And we got it. All right, let's end now talking. I got to do horizontal and vertical lines. Sorry. So a horizontal line is given by the equation of the form just y is equal to b. And this is b is the y-intercept of the line, and it has slope 0. So a horizontal line just looks like this. This is the value b. And then the line just looks like that. That's it. So whenever you see it says graph y is equal to b, you just go to whatever b is, and then you draw a horizontal line. That's it. Vertical line, instead, it just says vertical line is given by the equation now x is equal to a. And this is where a is the x-intercept of the line. And these vertical lines, the slope is called undefined. Okay. The reason this one, going back, has slope 0, horizontal line, because you rise 0 to get to the next point, and then you run whatever. It doesn't matter. It's always 0 over whatever number you pick. This one here, a vertical line, if I say graph the line x is equal to a, sorry about that. You just go to a, and then you just draw a vertical line. So the slope is undefined because if you pick 2 points on the line, all right, change in y is this amount, but change in x is 0, and you can never divide by 0. All right, so let's do an example just so you can see this. So let's sketch the graphs of y is equal to 3 and x is equal to minus 2, and let's find the point of their intersection. Okay, so where the lines intersect. So this right here is going to be a horizontal line. So I'm going to go to y is equal to 3. Okay. So I'm going to go to y is equal to 3 right here. And I'm just going to draw this horizontal line like this. Okay, so this is the line y is equal to 3. Then I'm going to go to x is equal to -2. So this is a vertical line. So I'm going to go to x is equal to -2, and I'm just going to draw the vertical line here. All right, so actually, let's look where they intersect. Ah, right there. They intersect right there. That's the point -2, 3. Okay. Now let's end. Now let's talk about graphing a linear function or linear equation using the x and y intercept. So let's sketch the graph of y is equal to 4x minus 4, which also could be f of x is equal to 4x minus 4, by finding the x and y intercepts. Okay, so the y-intercept first. Okay, y-intercept occurs when x is equal to 0. So if you take my equation and just plug 0 in, right, the y-intercept is equal to -4. Now the x-intercept occurs when y is equal to 0. So I'm going to plug 0 in for y. And now just solve this. This is pretty easy to see. You add 4 to each side. You get 4 is equal to 4x. Divide by 4. And you get x is equal to 1. So right here, boom. That's the x-intercept. And you can see right here, that is the equation, because I just found 2 points. In this case, it's the y-intercept. And over here is the x-intercept. All right, class, a lot to digest here. A lot of formulas to follow, but if you just stick with the formulas, it'll be pretty straightforward. And a graph, you need 2 points on the line, or if you want to find the equation of a line, you need the slope, and then any point on the line.